Okay.
K is 3.
What this means is we're going to plug in all the values of k from 2 to 6, so 2, 3, 4, 5, 6, into here, and then all those values are going to get added together. So sigma is used to write series of numbers added together. If I plug into, are you guys going to giggle every time I say sigma?
He's just dying every time.
Okay, so if I plug in 2, that's the first one. 2 times 2 is 4. Plus, then you plug in 3. 2 times 3 is 6. Plus, plug in 4. Plug in 5. Plug in 6. And that's it. You add them together. Hold on. This would be 20 plus 10 plus 10. That's 30. Anyway. So, yeah, you just plug in 2, 3, 4, 5, 6, and you add all those terms together. So really it's a series. It's just a bunch of numbers added together that are in a pattern of some kind. Okay? So on number 1, oh, it's 2 to 6 also. I can cheat. Okay, for number 1, we're doing k equal, or the sum of k. How did they say this? Sum of k when k is 2 to 6? I don't know. I don't know how to verbalize it.
Now, are you sure you can count?
Hmm?
Never mind.
It wasn't on here, like, you know what?
I'm trying to see if they say how to verbalize it.
I don't think I do.
The sum of k for values of k from 1 to 6. Yeah, that's how you say it. The sum of k for values of k from 2 to 6. So, k is 2, k is 3, k is 4, k is 5, k is 6. Okay, on number 1, you don't actually have to add it. We're just writing it in expanded form. So, that's all that is. Okay, so number 3, sigma k equals 1, 2, 5, and then it's k, 1 over k. Alright, so it'll be 1 over 1, which is 1, and it'll be 1 over 2, it'll be 1 over 3, and 1 over 4, and 1 over 5. Maybe we should have gone to 20. Why did I put 18? 16.
For fun, you know, because you want to give us a little slack.
Why is ours so much harder?
Why is yours harder? Oh, because number 4?
Yeah.
God forbid we have to do a little bit of
It
math.
sucks. It's horrible.
Hey, doing math in my class is my least favorite thing.
Okay, number 5. So number 5 is going from 0 to infinity and beyond. All right.
Sigma.
So, hope you're fired.
You're saying it.
But like he's saying it cooler. Nonchalant.
Exactly.
Man.
When I said it, it sounded cool. Okay, so we can't actually put an infinite number of terms down.
It's not even.
Uh-oh, guys.
It's not even how you do it.
Laura's thing went off.
Man, shut up.
Okay,
Check your
so we're starting with 0. If I plug in 0 right there, I get 3 to the 1, which is 3. Plus, if I plug in 1, 1 minus 1 is 0, 3 to the 0 is 1. If I plug in 2, 1 minus 2 is negative 1, 3 to the negative 1. Do you guys know what that is? Right there. You guys know what the pattern is yet? Okay, let's do another one. I plug in 3 is the next one, I guess. 1 minus 3 is negative 2. 3 to the negative 2 is 1/9. Yeah, it's times a third. Okay, now we can't go forever. We can't actually get to infinity. So yeah, this is where we give up and say dot dot dot. There.
It's a rapid fire knock.
On 7, we're going from t equals negative 2 to 2. And we're doing 4 to the t. Alright, 4 to the negative 2. It's like 4 squared but upside down. So it's 1/16. 4 to the negative 1. 4 to the 0. 4 to the 1. 4 to the 2. Okay, number 9 is where we have to use our brains a little bit. It's write your own series using sigma notation. Okay, so we kind of have to recognize the pattern. What is the pattern on number 9? How do you get from 4 to 8 to 12? You could add 4 over and over. Yeah. That should do it. So, yeah. There's more than one way. I think the easiest way to do this would be the first term is 4 times 1, the second term is 4 times 2, the third term is 4 times 3, right? So if we make our sigma 4 times n, and then just start counting with n from 1 and up. How far does it go to 20? So it goes to 4 times 5, which is 20. So n needs to go from 1 to 5. 'Cause 4 times 5 is our last term. And then it's just 4 times n.
Whoa.
You could say it's like 0 plus 4n, but yeah. It's just 4n is fine. Okay. Number 11. What is the pattern? This one is a 5, 9, 13. This is a plus 4 pattern. But instead of starting on 4, we're starting on 5. So, let's see, what's the last term? The last term is 101. 100 is like 25 times 4 plus 1. So the pattern basically is 4 times n, but it's plus 1. If 11 looks like number 9, but all the terms are 1 bigger. So our little formula will be 4n plus 1. It just makes everything 1 bigger. And we'll be counting from 1 to 25, because 4 times 25 is 100. So this would give us 101. Okay, are the evens difficult? What's the pattern on number 10? Times 2. Do you remember how we multiplied by 2 over and over again?
With the square root.
Put the exponent as a variable.
Oh, that's right, nice. I just figured about that.
Okay, on 13, what's the pattern? You guys remember 4, 9, 16? We've seen this a few times, this chapter. What's the pattern with these?
Square.
Yeah, these are square numbers. 2 squared, 3 squared, 4 squared. So I'll use, but these are all like in the denominator. So it'll be 1 over n squared. Will be our little formula. And we're starting with 1 here. You don't have to start with 1. It's just kind of whatever is more useful. Okay, it gives the ellipses. You guys know what ellipses is? Dot, dot, dot. Which means it's going to go forever, so we're going to infinity.
This one was kind of easy. We have one more question.
You just jinxed us. I hope you're happy.
What?
This would have been a better Wednesday assignment than
Oh,
today.
I see. Well, that one doesn't look good.
Man.
Well, at least 16's kind of easy.
Well, 15 is no problem. Okay, what's the pattern on 15? There's a 1x, there's a 2x, there's a 3x inside the sign. So all we have to do is make it, well, maybe I should use something besides it. That's fine. So we'll just call it nx. How far does this one go? Forever? The book likes using k for some reason. Guess that's all, folks.